about 1.4 elementary function. In this subtopic, we will learn about examples of elementary function and is divided into three parts: piecewise defined function, certain even and odd function, and thirdly, increasing and decreasing function. Okay, for piecewise defined function has different formulas in different parts of the domain. So if you guys can look at this graph, this have a different function and different graph. So how we want to write our graph into piecewise function? So firstly, we look at this graph. This graph is a quadratic function, but our quadratic have a district, and our district is called a domain. So for domain, first we look at what type of our graph. Okay, our graph is a quadratic, so we written as x square, and it's just not it's just a square. So our domain 1 until, so our arrow is until infinity. It doesn't write any part of domain. So our domain x, so we must write x is small and same as 1. Okay, next we look at this graph. This graph is at y equal to 3. So this is 3, and so all along this sepanjang y equals to 3, but it have a domain 1 and 2, but 1 is a empty circle, maksudnya tak termasuk, and this is closed circle, which is termasuk 2. Okay, next this is a linear graph. So our linear graph must be written as x, and then this is 2. So our domain is x is greater than 2 dan tak termasuk. So just need 2 until, so the domain is 2 until infinity. So just write x is greater than 2. Okay, next we will look at even and odd function. Okay, so for even and odd function, let's watch this video.
Even functions and odd functions. A function y equals f of x is an even function of x if f of negative x equals f of x, or it is an odd function of x if f of negative x equals negative of f of x for every x in the function's domain. If the function doesn't satisfy either of the above properties, then it is neither an even function nor an odd function. The names even and odd come from powers of x. If y is an even power of x, as in y equals x square and y equals x raised to the power 4, it is an even function of x, because square of negative x equals x square, and negative x raised to the power 4 equals x raised to the power 4. If y is an odd power of x, as in y equals x and y equals x cubed, it is an odd function of x, because the first power of negative x equals negative of x, and cube of negative x equals negative of x cubed. The graph of an even function is symmetric about the y-axis. This is because, in case of an even function, the value of y is same for x and negative x. The graph of an even function does not change if we reflect it across y-axis. The graph of an odd function is symmetric about the origin. This is because the value of y at negative x is the negative of the value of y at x. The graph of an odd function does not change if we rotate it by 180 degrees about the origin. Let's rotate the graph by 180 degrees clockwise. Now let's rotate the graph by 180 degrees anti-clockwise. Clearly, the graph remains unchanged in both the cases.
Okay, so I will explain a bit from that video. Okay, even an odd function, if a function f satisfies f negative x equal to fx for every x in its domain, then function is called an even function. So, geometrically, the graph will be symmetric with respect to y-axis. So we can say we can say it will symmetry with respect to y-axis. Okay, this y-axis. Okay, next is a function f satisfy f negative x equal to negative f equal to x. So remind that this concept. Okay, for every x in its domain, then f is called an odd function. So geometrically, the graph will be symmetric about the origin. Rotating the graph at 180 degrees about the origin will not change the function, like what we watched in that video. Okay, so geometric graph will be symmetric about the origin. So such as such as this is our point, this is x, y. So in this point, because it's reflect symmetry with the origin, our origin. Okay, so the value is negative x and negative y. Okay, so like that. Okay, next we will see example of odd function. Okay, this is our function given. This is our function, and then we just substitute to identify whether there is odd function or even. We must substitute negative x into x. Okay, substitute negative x power of 5 plus 3 negative x power of 3, and then calculate that, and we will get the answer is negative fx. So our concept, so we get our concept is okay, f negative fx equal to negative fx. So it's proven that this function is an odd function. Okay, next we look at example of even function. Given function fx equal to negative x squared plus 4. Okay, same, we must substitute negative x into the value of x. So negative x, substitute negative x power of 2 plus 4, negative 3x power of 2 plus 4, and the answer is negative 3x power of 2 plus 4, same like above. So this sign is not changed. So when f negative fx equal to fx, so it's proven that this function is even function. Okay. Okay, lastly we will learn about increasing and decreasing function. A function f is said to be increasing on an interval if value of x1 is less than value of x2 whenever x1 is less than x2 in that interval. Okay, a function f is said to be decreasing on interval if x1 is greater than fx2 whenever x1 is less than x2 in interval. Okay, so we look at our this graph. So such as this is the value of x1 and this the value of x2. So you can look at this from the lower value to the higher value. So this is called an increasing increasing function, interval lah. So this is interval. Okay, next we look at this function. Okay, this function we can made up this interval, our interval. Okay, from this to this, maybe this is x1. Okay, the value is 10, this value is 0. From the higher value to the lower value, so this is called decreasing. Okay, decreasing. Okay, next from lower value to the higher value, so it should be increasing. Okay, that's all from me. Thank you.